The main part of this session is regarding dictionaries. Dictionaries are the last container that we'll look at. Of course, just looking back at all of the object types that we've learned, we had the atomic types, int, float, and string. We have the container types, set, tuple, list, and now dict. And then we also had the Boolean type and the none type. These are the types for Boolean is for true, false. None type is for the null value or none value, which is Python's empty value. So now a dictionary. Dictionary being the last type that we'll be looking at, the last major type, and the only container remaining to be seen. I want you to look closely at lines 2 and 4 and see if you can note the syntactic differences. So you probably noticed the colon. The colon separates a pair in a dictionary. What we're looking at below here is a set, although I changed the items to a very unusual configuration just to show you the difference and sort of point out these differences. Normally, of course, we wouldn't have a set that looks like this. Normally, we would have a set that looks like this or has numbers. Normally, a set is going to be homogeneous. But the main point is that the notation for a dictionary is very different. Whereas in a set, we have individual items that are unique. In a dictionary, we have pairs. And as it turns out, a dictionary is very much like a set in the sense that dictionary keys are unique. So I could even put in a second dictionary pair, and I would see that last addition, but you'll see that it replaced the other addition, or the other A. So here you can see I have A is 100 and B is 2. The original A, the A that was originally initialized to 1, that's been replaced now, or at least we can say that the value has been replaced with 100. Dictionaries are pairs with unique keys. Unique keys means that the keys are unique, very much like a set. And when we say key, of course, we're talking about the first item in the colon-separated pair. So A is a key, 1 is a value, B is a key, 2 is a value. A, let's just make this C. C is a key, and 100 is a value. These are paired in the sense that if we wanted to look at the value for C, we could print x dict C. What we're doing here is asking for a value based on a key. And this is one reason that a dictionary is also known as a lookup table, or sometimes known as a hash map. That's less important. But the reason we call it a dictionary or a lookup table is that it keys some, sort of definition, or no, I shouldn't say definition. It keys a key, which can be a string or a number, to a value. And so we can do lookups on the values based on the key. And one question I often get is whether you can look up a key based on a value. No, that's not how a dictionary works. It's a one-way lookup table. We use dictionaries to pair keys that are important to us to values that help qualify that key. For example, I might have a list of companies and their capitalization. The Acme company, the Beta company, the Cool company. And we can say that the Acme company is capitalized at 100 million, Beta at 2 million, Cool at another 100 million, or a Cool 100 million, or we can say 105 million. And if we're interested in finding out the market capitalization for a particular company, once this dictionary has been built, we can just ask. That's what a lookup table is for. And you can think of a lookup table as having keys that represent any unique set that has an associated value. For example, students and their GPA, employees and their salaries, companies and their market cap, planets and their mass. In each one of these, we've got an important qualifying value that's associated with a unique key. For example, if I had a table of states and their population, you wouldn't expect to see the same state twice. So this is why keys are unique. The nature of the data that we use to describe the nature of the data that we use in a dictionary is used to describe unique keys with qualifying values that help describe that key. So as I say, it can be any kind of unique listing of things with a value associated. And you can think of a lot of examples of this where we might want to, let's say, rank students by their test scores, or rank athletes by their sports scores, or rank companies by their market cap. This is what a dictionary is generally used for. Now, in order to set a key value pair, this is us reading a key value pair. So read a value based on a key. And then the other thing that we may want to do is set a value based on a key. So if I wanted to create another key in this, I might want to set the denim company's market capitalization to 55 million. When I'm done, I'm going to see that denim has been added. Now, as I mentioned before, if I used the same key more than once, we're going to find that that key gets overwritten. And that's really important because sometimes we're going to actually rely on that functionality. But what we're starting with now is just the reading and writing of key value pairs. Now I want to underscore the difference in syntax. This is reading key value pair, and this is writing key value pair. Actually, I should say we're not really reading, we're reading a value from a key. So we're looking up the value based on a key. Now I want you to look closely at the syntax between line 6 and line 8. In line 6, we're reading. In line 8, we're writing. Think of any assignment, and I'm sure you've begun to do this, think of any assignment as occurring from right to left. That is, the value on the right shall be assigned to the name on the left. In line 4, we're assigning a dictionary to a name, right? So we're creating a new dictionary object. In line 6, what we're doing is reading the value for cool. We're reading the value for cool by assigning the dictionary subscript key, which you may notice, this subscript is the same as it was for a list. We're assigning that value from right to left. Now, one of the big sticking points for students is in recognizing this syntax and then, of course, in using it. On line 6, we're reading the value for cool, which means that cool cap will be 105. The value for cool cap will be 105. On line 8, however, we are basically setting a key value pair. We are writing a key value pair to the dictionary. So we've set up a new key value pair with key denim and value 55. So similar to a list, when we start building up a dictionary from data, which is going to be one of the main things that we do, given a data source, given some sort of file that has a unique key and a value we'd like to associate it with, we want to build up a dictionary from a data source. Similar to the list, in which we might say mylist.append new value, this is us adding a value to a list, or my set.add, as you may remember, adding a value to a set. We are doing the same thing with the dictionary. So we may say adding key value pair to a dictionary. Now, as I say, one of the most challenging things is in dealing with this new syntax. So far, we've been led to believe that the way that you add to a container is using a method, like append or add. With a dictionary, it's just different. I wish it wasn't different, but it is. Look closely at line 8. We are setting a key value pair. On line 6, we are reading a value based on a key. So please, as far as you can, familiarize yourself with the syntax and understand anytime we want to add a key value pair, we're going to use the syntax in line 8. And anytime we want to read the value for a key, we're going to use the syntax on line 6.